Hello, in today's video we're going to be talking about redox reactions. So this is a continuation of that oxidation reduction chemistry that we learned on the last video, assigning oxidation numbers to each of the elements. Now, previously in the previous video we talked about how to assign an oxidation number given a certain compound. Now we want to figure out which of the elements and which of the compounds has been oxidized and which one has been reduced. So I'll talk about why we want to know that a little bit more in class tomorrow. However, I want to go through the procedure in the video tonight. So we have some mnemonics, and you're gonna learn a different one tomorrow, but the one that I go by in order to identify the oxidizing agent and the reducing agent, or what was oxidized and what was reduced, is Leo the lion says grr. So Leo the lion says grr. Okay. So the capital, the words with the capitalized letters are going to be what tell us how we're going to use this mnemonic. So let's take Leo. It stands for lose electrons. That means you are oxidized. Okay. So lose electrons, oxidized. Grr stands for gain electrons, you're reduced. Okay? So reduced, yeah. So what this means is we have to figure out which of the elements has gained electrons going from one side of the equation to the other, and which one has lost electrons going from one side of the equation to the other. What that means is we have to assign oxidation numbers to each of the elements that are present within this whole equation. So let's do that. We know we have a rule for group 1. Everything in group 1, they're going to take a +1 oxidation number. We also, from that, can figure out what the oxidation number is on nitrogen. It is a 3-. So this isn't an ionically bonded system, it's a covalently bonded system. That 3- can be in the front. That is not the charge, that is the oxidation number. It's a different type of entity. Okay, so the negatives can go in the front, that's okay. O2, this is our first rule on that table of oxidation number rules. This is in its natural state. It gets an oxidation number of 0. NO, nitrogen monoxide. We don't know what nitrogen is. We don't have a rule for that, but we do have one for oxygen. When it's in a compound or a molecule, it'll always take a -2 oxidation number, which means nitrogen is going to be a 2+. The stoichiometric coefficients don't play a part when we're dealing with the actual oxidation numbers. They don't have anything, they don't affect it at all. Here, again, oxygen's a 2-, and again, H, since it's in group 1, will be a +1 oxidation number. So now, I want to figure out which of the elements, and I will specifically state if I'm asking you for the compound or for the element, but in this case, I want to talk about the element that has been oxidized. So something had to have lost an electron going from here to here, or going from the left-hand side to the right-hand side. What that means is if you lose electrons, you're losing your negative charges. That means you become more positive. It's the same thing with personalities. If you aren't a negative person, if you get rid of your negative thoughts, you become more positive. Same exact type of thing here. So let's check. We're gonna tie these together somehow. Nitrogen was a 3- on the left-hand side of the equation, but now it's a 2+. It became more positive. That means it has to have lost electrons. So I'm going to draw a line connecting these two. This is called a tie line, and it allows me to easily identify which of the two elements, which ones of them are playing a part in the oxidation reduction chemistry. Okay. Hydrogen was a +1. Hydrogen's still a +1. It doesn't change. Oxygen here is a 0. Oxygen's a -2 here and a -2 here. Okay. So sometimes you'll get the element split like this. That's perfectly okay. What you can do is you can draw a single line that goes to both of these. You can do that. Sometimes one of the oxygens over here won't have change oxidation numbers and you won't have to draw a line to it. So we'll do a lot of examples like this tomorrow. So now we have our tie lines. anytime you have one tie line, you will always have another. If something is oxidized, something has to have been reduced. Always happens. It will never not happen. What that means is you are always going to get 2 lines or no lines. If you get 1 line, you've done something incorrectly. Okay, so now let's see which one was oxidized, which one was reduced. So nitrogen went from 3- to a 2+. It became more positive. That means it was oxidized. Oxidized. It lost electrons. It's oxidized. Well, now we have to make sure that oxygen gained electrons. It became more negative. If it didn't, we've done something wrong. So oxygen was a 0 and went to a 2- over on this side. So it became more negative. It gained electrons. So it's reduced. Reduced. So that's how we assign the oxidized element and the reduced element. So I could say nitrogen is oxidized, and oxygen is reduced. Nitrogen is oxidized, oxygen is reduced. Great. Now we can identify which compound acts as the oxidizing agent and which compound acts as the reducing agent. So the thing acting as the oxidizing agent is the compound. It has to be one of the reactants, is the compound that allowed the other element to be oxidized. So it's kind of the reverse thinking. So oxygen gained electrons in this reaction, which means it allowed the nitrogen to lose electrons. So oxygen, the molecule of oxygen, is actually your oxidizing agent. So even though it was reduced, it's called your oxidizing agent. Now nitrogen gave up its electrons, allowing oxygen to become negative, to get a negative oxidation number. What that means is it was the one allowing the oxygen to be reduced, so it is called your reducing agent. An easy way to remember this, if you can figure out what was oxidized, you know that the molecule it's a part of, NH3 in this case, would be considered the reducing agent. It's the opposite agent. Oxygen was reduced, therefore it is the O2 is the oxidizing agent. So it's always the reverse. Whatever's oxidized, the compound it's a part of is the reducing agent. Whatever's reduced, the compound it's a part of is the oxidizing agent. And with that, I want to say that's all you need to know about oxidation reduction reactions, also known as redox reactions. We're going to cover a lot of these problems in class tomorrow. Don't worry if it doesn't make a whole lot of sense right now. I just wanted to show you how we go about solving these problems. So have a great night. I will see you all in class tomorrow.